Hello, this is Michael Amalfitano, and this is group number 5 of section 13 of aero experiments from 1:30 to 4:20 on Tuesday, and this is going to be lab 4. So we're going to make the wind tunnel as normal. Okay, now we have to make the flat plate in the middle. So what I'm going to start by doing is making a rectangle, and I want to make this really far back just so that it doesn't get messed up at all. Um, I'm just going to make a vertical thing right there. I'm going to dimension the flat plate. So it is 23 centimeters long and 0.26 centimeters thick. That line never got rid of. There you go. And then on to draw a line from here. Let me undo that. I need it to be roughly need it to be a horizontal line. Then I need to dimension this horizontal line, and that needs to be 4.45 centimeters. And now to make sure I don't mess anything up, I'm going to get rid of that really quick. And then I'm going to draw a line from this top. Make sure it's a vertical line. Then I'm going to dimension this vertically from here to here. And this needs to be 8.22. So it's centered in the test section rather than centered on the axis. Let me just draw this line one more time to make sure it didn't get messed up. 8.22 and 4.5. All these numbers look good. The wind tunnel is not messed up in any way, so they're now going to trim all of these away and just leave us with our plate in the middle. And make sure our wind tunnel isn't included, or our wind tunnel is included, but the plate isn't, so that's all good. Looks good. We're back in the mesher. Let's just zoom in, and while we're here, let's name everything. So let's make sure we're on edge select and name this the velocity and the walls, name this the pressure outlet. Nice. And now let's go back down here. This is going to be named top of the plate. This is going to be named bottom plate. This is going to be named back plate. And this is going to be named front plate. Let's top plate, bottom plate, back plate, front plate. Everything looks good. Let's go to mesh method. triangle. 0.0015 is the size I'm going to use. Now that I'm here, I'm going to you get back on edge select. I want to select all pieces of the flat plate. It says 4 edges, which means it got all of them. That's good. We need to make this 0.0015, so it'll be 10 times smaller. Everything else looks good. This looks good. So now we'll just generate, and I'll be back when that's done. I'm going to finish meshing, and you see the mesh looks good from out zoomed out, and then you zoom in and you can see it. And then you see that it gets finer and finer to the surface of the flat plate, and that's exactly what we want. So we're good here. So you want to just update this. And then I'm going to click on setup, and I'll be back when that's loaded. Just wanted to point out, make sure you're on double precision. Alright, it all the way opened up, so what we gotta do is we need to check on models. And we want to go to here. We want to put on viscous laminar. Make sure it says viscous laminar. Materials, fluid, make sure you're on air. These values all look good. Boundary conditions, we're on inlet, velocity inlet. So based on the area ratio and our values for the test section velocity, I got a value of 2.371 at the velocity inlet. So that's good. We'll go to initialization. We need to initialize, and I'll be back. All right, we did initialized. So now we're gonna go to run calculation. I'm gonna put on 1,000 iterations because it gets better results, and then click calculate, and I'll be back when it's done. Okay, it finished. So what we're gonna do here now is we need to find the we need to make a new line reg. I'm gonna name these X1 to 3, but these are gonna be lines in the test section on top of the plate. So based on the geometry of the wind tunnel and where I placed the plate, we need to go 0.2 centimeters in from the front, so that would actually be at negative 0.112 meters. And we want to just do it at a single point, so the x's will be the same, and the y's we want to raise it. So 0.0013 is actually the top of the wind tunnel, or on top of the flat plate, sorry. And then 0.0043 will be above that, just to give us a little bit of room to see if we can capture uh, the boundary layer. So I'm going to make sure those values are right and then create it, yep. So X1 is there. I'm going to create the next two as well. So X2, this one is going to be negative 0.034. This one is going to be 6 centimeters or 8 centimeters in from the front of the plate. Okay, it's gonna be on top of it for the on top of the flat plate, which is where the 0.0013 comes in, and then we're just gonna make this bigger than the last one by about, a few millimeters. Create that one, that's X2. Now we're going to create one more, or wrong button. This is going to be the third X location. We'll call it X3. So this one is going to be at positive 0.046. So that is 16 centimeters past the front. We're going to do the same thing here, and then we're going to make it another 10 millimeters. And then we're going to create that one. Now that we have that done, we're going to go down here to plots. We're going to do X and Y plot. I'm going to call this X1. I'm going to do velocity, velocity magnitude, curve length, and we're going to do this on X1. This is what it should look like, and then you can write to file and stuff. Okay, close that one. I'm going to make another one. Velocity, curve length, X2, save plot. You can export that one as well. That looks good. Close. Oh, it didn't get renamed. Just call it X2. There we go. And then we're going to make another one. This is going to be X3, velocity, curve length, X3, save and plot. Looks good. And then you'll save or write to file to figure out where the boundary layer is. Then we gotta close this. Now we're gonna make another new one. This one we're gonna call wall shear stress, and this one we're gonna do wall fluxes, wall shear stress. Then we're gonna do this on the top of the plate. It should be more at the front, so this looks decent. Looks good. And then you can obviously write that to file, and then we also want the skin friction coefficient in the same area. That looks good as well. You can write to file as well, and that looks all good. Now that that's done, we want to actually come back up here to report definitions. We want to new force. We want drag. So we're going to select all of the plate surfaces. We're going to start off with drag force. Just going to compute that, and then we'll switch it over to coefficient and compute that. And then it's down here at the bottom. These numbers are okay, so we're good with that. And then I'm going to go to the solution thing, and I'm going to make the velocity contour. Now that we're here, I'm going to click on this Z, and then what I want to do is come down to here. To insert a contour, I'm going to call this velocity contour. And then we want this on the surface body on the symmetry 1. We want velocity. We want global. Number of contours, let's just do something like 100. And see where that gets us. Give it a second. So the flow will start to reverse. This didn't come out as the same as when I did the first time. It actually went up at the end, but that's okay. Um, also want to insert vectors, so this is going to be velocity vectors. And here we're going to want the factor to remain 1. We want a line arrow of 0.05. We want to normalize. I'm going to apply that. We'll put that along symmetry 1 as well. I forgot to select that. Maybe it was surface body. No, that's not good. Sorry, this should be the right settings. I got confused. Figured out the problem. You just have to go to color, constant, and I made them black so they're easy to see. And there we go. You can see everything, how it's flowing throughout, and then you can, ooh, I don't want to do that. You can adjust where the legend is to, um, I'm going to change this to none and change this to this, and then change this to this. And it'll give it a nice location that you can see that. And that's the rest of the lab. Thank you.